Hello, this is Rochelle Agatha, and this is the lecture on if statements. And please note that if you're watching this lecture, it might have been taped in a previous term from the term that you're in, and the numbers might have changed, but the actual lecture itself covers if statements. If statements are very powerful. In Excel, an if statement returns a value if true and a value if false. So here's the condition that you actually write the if statement. So you say equals if, and then the condition, then the value if true, and the value if false. So the actual if statement itself is very easy to write. The condition is the value that you want to test. The value if true is what you want the condition to evaluate if true, and the value if false is what you want it to evaluate if false. So let's start out and work through an example. Here we have some children and their ages. So we've set up a table. Here's the table stating what grade the child will be in based on their age. So if a child is at the lowest 4, at the highest 5, they go to kindergarten. So let's try writing an if statement first for that. So we come over here and we're going to look inside the formula. And we're going to see that I wrote if C13 equals L13, then put a K. If not, then false. So I started out very simple, and I actually put everything inside the if statement. So notice that I absoluted certain cells. So the purpose of the absolute is that you want the formula to be able to copy down and still refer to a set cell in a corresponding table. So let me get out of this. So you can see as I copy down, that L13 stays the same. And all these are false because the age of the child is not what I'm asking it to be. So for instance here, C15 is not 4, so it's false. I could write anything here. I could write, let's try no. And it puts no. Okay, notice that the no I had to put in quotes. The false is the way the Excel function is written. Anything else has to be inside of quotes. Notice when I get to Tan, she's 4, and so a K is resulted. Everybody else is not 4, so a false is done. Let's say that I didn't actually want to type the K in here, that I wanted to refer to the table. I can do that too by coming over here and absoluting, and then I can copy this down. And notice I'm going to do a paste special because I don't want my formatting to come with me, like any weird lines or anything. And then it still has results in that K. Okay, so that's a simple if statement. Write it first. As you're going through this lecture, test what I'm doing yourself, because this will help you understand as you get to the nested if statements. Now we're going to go through and look at, and this file will be attached inside your assignment so you can follow it and you can see what I wrote here. A1 is a simple example that assumes anyone that's 4 is a kindergartner. Okay. Now we're going to example A2. A2 is saying, okay, let's grab anyone who's going to go to kindergarten, and that is going to be anyone who's between 4 and 5. So in here I said if C13 is less than or equal to M13, then they're going to be N13. Okay, so let's follow that along. So a 7-year-old is false, a 6-year-old is false. Now notice that false comes up whether I put false up here or not. So let's go back and look at these two. See how this one I actually wrote false? This one I didn't? It will return a false no matter what, because if there's no second false condition, it produces a false. I get in the habit of putting the false there to remind myself to always put the false condition. What happened here? Here is 3. He shouldn't be going to kindergarten. Well, the reason that it's happening is because I'm saying anything lower than 5 is going to go to kindergarten. So I'm showing you what happens when you write an if statement if you don't really map it out. And the best way to map out an if statement is to do it on paper. Build your table and then mathematically write off to the side what you want to happen if true, what you want to happen in false, and make sure it can happen. If you're not mathematically inclined, that's okay. You can still do this in words and then formulate the if statement. So as you come on down, it's working for everybody who's not, who's 5 or 4, but it's not working for anyone lower. So let's even change Hiram to 2. The same thing's going to happen. He's going to go to kindergarten either which way because of the way I wrote the if statement. So this is a wrong example, but I'm close. How do I fix that example? I need 2 if statements. I need what happens if it's true and what happens if it's not true. So what I've done here is I say if C13 is less than L13, then NA. Okay, so if you're less than 4, you're not going to school. And I could have written anything here. I could have written preschool, and I'll show you that in a minute. Then my second condition is another if statement. If C13 is less than M13, then N13. If statements work from right to left, the logic from left to right. The logic starts here and it follows the logic in that order. So you must always think about what you want to not be true first. Okay? So let's come down here. Notice it's working now. Hiram's 3. He's not going to go to school. Let's make this person Sam 2. And notice it's working too. Okay? I can change this to anything. I could actually say preschool. And they're going to go to preschool. So anything you want to put inside those quotes is what's going to show up there. So this is cool. This is working now just for kindergartners. Okay, let's work our way up the line. Now let's say we want to figure out, make it work for first graders. We build on this if statement and we just add, we have our first if statement if they go to preschool. If not, if they're less than 5, they're going to go to kindergarten. Then if they're less than 6, they're going to go to first grade. And you're probably asking yourself, well, if they're less than 6, they're also less than 5, right? But the less than 5 logic has already been tested and returned the K. So as you notice, Billy's 6, he's going to first grade. Hiram's 3 is not going anywhere. Tan's in kindergarten and Rose is in kindergarten. And everybody else is false because they're older than 6. So I can change somebody here and I can make another, let's make another 6-year-old. And you will see it returned the first grade. Okay, now I'm going to go across and I'm going to work that example for second grade. So notice I've just added another if statement. Notice, pay attention to how many times you close your parentheses. Excel will guide you if you try to close before you put all your parentheses in. Let me show you what will happen. If I take a parenthesis out and I hit enter, it says it found an error in my formula. Do you want to proceed? And I'll just say yes because it didn't have enough parentheses. Now Sarah, who's 7, she's going to second grade. My first graders and my kindergartners are still working. Anyone older than 7 is still resulting in a false. Okay, let's move over. Now I'm building this for you so you can see the power of the if statement. Now look at up here. I've nested myself 1, 2, 3, 4, 5 times. Okay, I'm down to the 5th level of my table. Now anyone who is up less than 9 or less is going to have a grade associated with them. So there's my second, my first, my Ks, my preschoolers, and then here's my people who are older than 9 that have nowhere to go yet. Here's my final example of what it looks like when all's said and done. Everybody's going somewhere. I've nested myself all times of the table, and I've gotten a place for everyone to go. So what if I make somebody 25? Goes 25. That doesn't look right, does it? If 25, they're not going to go to middle school. They're not going to be in school. Middle school says that anyone between 12 and 14 is middle school. And here, I have a 15-year-old going to middle school. So in your mind, I want you to think about what would I need to do to fix this? Because here I'm saying if C22 is greater than L18, which is here, then they go to middle school. What I really need to do is build one more level that says if they're less than 14 or less, they go to middle school. And then if they're greater than 14, then they're not in school. That would be my last example here. So that, in a nutshell, I know I've said a lot. I'm going to attach this file inside your lecture so that you can see the different if statements, so that you can build the assignment that I'm giving you. The assignment is actually a table that you're going to create. You're going to create the table as you see it, which I explain in the words, and you're going to put all the information you see here. Then you're going to build an if statement that's going to look at the type and come down and look at the type here and produce a life. And then from that, you're going to calculate annual depreciation by taking cost divided by life. And if you're not an accounting major, I try to keep this fairly simple because some of you haven't taken financial accounting yet. I tell you down below that annual depreciation is cost divided by life. The key to this assignment is to get your if statement. You should be able to write this if statement, which I define down here in all the different words. Yeah, I know you know how to read. By going back to my lecture assignment and using the kindergarten grade example, because you're going to need a nested if statement to pull any of these different examples from this different table. I suggest you try the one I did on your own and make sure you can do it, and then come into the example and do the actual assignment. Please note, as I mentioned, this lecture might have been stated or recorded at a time different than the term that you're in, and so these numbers might look different, but the assignment is the same. If you have any questions, send me an email. Thank you.